Hey folks, how are you? So today let's try to create a gateway using Spring Boot and AI. So what we want to do is we just want to spin a gateway using AI. So I'll be using free ChatGPT account to do this. I'll spin up a full working. Now without AI, you'll be replaced by developers who know how to use AI because of their speed and how quickly they can deliver on their task or doing the application. So I'll tell it, so I'll not start, of course, I'll just do a prompt, say I want to create a Spring Boot architecture. So this one, at least we know why we are creating why we are creating this gateway first, to just get to understand why do we need this gateway and what are the importance. So API gateway is it's a crucial component in microservice architecture, and it acts as a single entry point for all client requests to help manage the routes, secure these endpoints across multiple devices. So it's a single entry point for all the microservices. So assuming we're having a number of microservices, there'll be, assume we have this, let me see. This, yes. So let's say this is our entry point. I'll make it a bit wider. So let's say this is our entry point to our application. Or maybe this is a mobile app. Guys are using mobile apps on the other end. And then we have a number of Spring Boot services. So they're accessing our web via devices over there. And then we have a number of, we have maybe a queuing service, and then we have a number of Spring Boot services around the same. So let me just do this one quickly. Maybe say you have things like containerized items, and then let me just show you. I have a front end. Then let me just put all these components in here, and then we give it, maybe you're using ready somewhere, and so on there. Here is your client waking up in the morning to start to use your service. We have a Spring Boot service here. I can't find the Spring Boot. Okay, here we go. So here there's the start of your process. So let's say you have a client here who is trying to access your website from here. So this person is sending some multiple requests to your services. So let's say this is your DNS or something like that. And then maybe you have somewhere you've kept you have Dockerized your application. So let's just say this is a Docker container, and then it has a number of services. It has a number of services that you're using to, maybe this is service 1, this is service 2, this is service 3. So you have a number of services within this container of yours. Then you have used Docker and stuff. And then there's a Redis server here, which you're communicating to. And then outside that, probably there is, let's say there is just lying somewhere in your, within your server, you just have a queuing platform like Rabbit, ActiveMQ, or Kafka that you're using to do queuing from your service server when you put it as this. Yeah, so these are your services in Spring Boot. So before you can access these services, now what we want to do, instead of someone hitting all our services, which will have a different ports and different, maybe they're lying on different machine or different containers. So you'll have multiple ports in here. Let's say this one is lying on port, let's say this is on 8080 on a different IP. Let's say this one lies on dot, make it a bit bigger. So let's say this one lies on port 3.18080. This one lies on port IP 4.8080. This other one lies on maybe a different port here, like let's say 8081 or something like that. Or maybe even in a different machine. So the IP could be different and stuff like that. So instead of accessing this architecture by your client calling all these, and doing all these kind of requests to all these services. Maybe one is auth service. Let's say this is auth service. To get token, then they'll hit auth service, and then they'll hit maybe another, maybe onboarding service. Maybe they have another that is doing the reporting service. So instead of calling all these services differently, let's say this is that, this is this, and this is this, and then we have another one here to do CRM or CV. We have a CRM service here. So instead of this service of yours hitting all these services with different endpoints in configuration on React, so you just need to like set up just one communication, one channel here, and then you'll do now your gateway. So between these, maybe you can do something like firewall. So when this one person calls, maybe there's a firewall somewhere, either before the front end, or maybe after the front end, there's somewhere you put a firewall. I don't know if I can get something to demonstrate that here. Yeah, let's say you have a firewall here, and then after your firewall, now you'll do now your gateway service before you enter into this cluster of services that you have deployed. So in here, we'll have now the gateway service. So this is the architecture that I'm talking about, whereby you're doing a microservice layout, and then you'll have your gateway. So this gateway of yours will have a repository, or rather, it will have a list of routes or routes, which will be able to tell it, or rather advise it on what endpoint to call and on which particular like for example, you want to do auth, it will automatically know using your config server that you need to communicate either whatever is entering here. You need to like for authorization, you need to talk to auth service. For reporting, you need to talk to the reporting service. Any endpoint to do with CRM, you need to talk to the CRM service and stuff like that. So where this one now will enable us to do a number of items here. So this is what now we wanna see. Like there's a number of items here that this page of ours will allow us to do. Let's say something like now what we are checking in here. So this is the platform, this is the architecture that we want to see today. Our customer calls, and then this is how it goes. So in there, what our gateway will help us do is first it will give us a single entry point. Yeah, here, so we'll have a single entry point. That's number one. So it will give us a single entry point to our services. Number two, it will aggregate all the routes, rather all the routes. It will be aggregated to one service. So you'll see you don't need to about the microservices. You don't need to go to individual microservices. And here, routes incoming requests or appropriate microservices can aggregate requests from multiple microservices to a single response or rather. So all these microservices, either way, after they communicate to the microservices, they'll be sending their requests back here. So this is how it will be. So it will be, they'll also reply versa using the same way, or rather the same route back to our consumer. So also our consumer can receive a story like you can even do here. You can do even callbacks here. You see, so you'll have even callbacks. You can configure callbacks here, and so this one helps that your service are communicating in a one unison way, so that you don't have confusion in terms of routing your requests and also getting your responses. So also this one can help us to do security. So number two is this. I'll just put it here as notes. So number two is this. Three is for security reasons. So it can help us also do security management. And put it to extra large. Yeah, so by security, what do you mean? It will handle authentication authorization in one central point. So in here, we can just do auth and token request from this angle. So we don't need actually to do so from this gateway. we can still do now the authorization of the token request. It can be actually processed from here. You can do token and checksums from these particular services. So this particular gateway. So you don't need to go through any other service here to just get your token. So after you get your token in here, that token is what now you use to communicate or rather to communicate to other microservices. So that one will boost now our security. So you can enforce JWT. So we'll use JWT for our case and then do a microservice. So the benefit is you don't need to implement a security for individual services. So if we do a basic auth here or we do a JWT token, we'll not have to do on all the services. So in here, because this is within our cluster which is protected and we have only this one entry point, that's what this one means. So it will be beefed up security. Another thing is on load balancing. So you'll get that the distributed incoming traffic, we can distribute it rather across instances. So we can have let's say you can have two sites. So this one can be site 1, and then on site 2, you can just have this gateway replicated on site 2, and then now customers will be calling on to site 2, and then still it will access from another cluster on site 2. So this one also will now mean that your system will be very scalable, and also it will be fault tolerant. If one site is down, then the next site will pick up the traffic and continue processing. So for load balancing, you can use stuff like, you can say even here you're using, so if you're doing load balancing for this case, let me just try and demonstrate what we'll be doing. So if you're doing load balancing in here, we have something like this. So we'll have a load balancer here. Let's say call it something like you can use it stuff like HA proxy. You can use a number of technologies out there for so you can Google that and use it maybe to do load balancing. Yeah, so for this one, I'm not getting a good one. So you can have a load balancer here, whereby now this one will assist in terms of moving traffics either into that service or maybe even sending the same to this service here. So let's just try to demonstrate this. Yeah, so it can either send that traffic there or send it into a totally new or rather different cluster, a different gateway. So this will be another gateway here, just a replica of what you had, and then this one now is lying on site 2, and then this one now will have a cluster of services also which are integrating in there in a different site. And now these ones, they can share the background resources like this one, and let's say things like database, they can still also share stuffs like database also. So you can have one common database here which can be shared. So you'll find that all these services of yours can still just use one database to do the communication. So these shared services like the caching technology, the database, and the queues can be used or shared within different sites, but then these sites, wherever they'll be lying, will have a load balancer that balances all the traffic for system scalability. So that's another importance of having a gateway. And then after that, we have cross-cutting concerns. So central features that are commonly across microservices: logging, monitoring, rate limiting, and throttling. So this one is very important also. So you can do rate limiting on your gateway to prevent either the DDoS or the attacks in terms of abuse. So you'll protect your underlying services from overload coming from different access points on other clients. So also it can help you in caching, so it reduces competitive calls to microservices and improve response time. So by having that, it will really improve our calls. For example, if you're doing one call that is recurrent, or rather data doesn't really change very fast, so you can still have another Redis here to be used specifically for caching within, so caching those requests. And then instead of every time your microservices is going to, instead of every time your microservices has to go, you can do like this here. So instead of, for example, you're having one request to call customers and customer have not been updated, let's say for the whole day, we have no new customer, or maybe it's a monthly job that usually run at the end of the month. So instead of every time something comes here and then you'll have to, or maybe a request to pull a report needs to come to your gateway, and then your gateway calls your service, and then your service calls the database and then returns it back. So instead of that, Redis can save it. This data can be saved on your Redis, and then Redis cache, and then this cache will be now be being pulled. Instead of going to the background services and database, it will be pulling from here and then having a quick response time, and also responding with this cached data. Unless data has changed, then you can have monitoring to either check on or rather synchronize these Redis of yours, or maybe these Redis clusters that you're having here, to just synchronize and see at what point will this one now need a refresh. So this can gracefully do its refresh during the day or during the night, but then you have your you have your data at least not every time being calling or doing these expensive. That's another importance of having a gateway. Then there's stuff like protocol translations. It can translate between HTTP, WebSocket, gRPC, or other data format like XML. If you're having SOAP endpoints and maybe REST endpoints, you can literally have a ways of doing that. So this one will allow your microservices to evolve independently of the breaking client. Yeah, so even if you have here, you can have even a different technology here. Like you can even have a service done on something like Laravel, for example, as a different technology, or done on Python. You have a Python service here that will still remain the same in terms of pulling your data. You can have different types of technologies that you're using within your services, but all those will be handled within the same gateway. So that's the other advantage. So also we can have a microservice decoupling. So clients interact only with an API gateway, not individual microservices. So at least we have decoupled the microservices, and then no one will know how many services you're having at your background. So your system will be very robust. So this one will facilitate continuous deployment, also service versioning, because now you can version your services the way you want at the background, but now the gateway will just remain one. And now you'll be shipping out microservices. Also, this one improves performance in terms of you can implement caching and response aggregation. You can reduce chattiness between clients and services. So this one is give you a better user experience and a seamless flow, data flow, and also it will lower your network overhead. So in short, API gateways act as a smart traffic controller from microservices. So assume these, just take it as a street light, which does control all the traffic, and we have a seamless and smooth data transmissions between your system. So it improves security, it improves scalability, it improves maintainability, and also it enhances the client simplicity, so making it one of the essential feature in terms of production. So this is what we are doing today. So these are having all these advantages. Let's create our first gateway service or gateway microservice. So in here, I'll still just use AI tool to just guide me through, not to give me everything, but just to guide me through so that I make it very quickly. I've never created a gateway, so I'm just creating a few as we are learning. So let's give it a shot. So I'll just tell ChatGPT I want to create a microservice in Spring Boot. I'll call it MS. Let's say MS Bula Gateway, or MS Gateway service, right? So this means microservice gateway, or rather maybe if they are, I'm doing for a company, you can say MS, maybe Bula service or something like that. So just or YouTube service, whichever that you want. So I'll call it MS gateway service. Let me put this one in quote, and then after that I'll say, so what do I want? So I want you, so help me get this service scratch from scratch, yeah, from scratch. Hey, I've written scratch in a bad spelling, but let me see if the AI also is wise to understand that and give me a better option. So what we're expecting is it will take us to Spring Boot Initializer, initialize an app, and then it will also give us some technologies to use, some dependencies to use, and stuff like that. So we expect at least some number of, so here you go. So perfect. So let's create the Spring Boot API gateway service called this one from scratch. So I'll guide you step by step of using a Spring Cloud Gateway. So there's a dependency, or rather library called Spring Cloud Gateway that will help us do this. Okay. So which is standard choice of Spring Boot microservice gateway. So let's start. Let's give it a shot. So create a Spring Boot initializer by going to this Spring Boot initializer. So we'll go there first. And then in that, we need to configure our project using Maven, Java, and then Spring Boot 3.x. We'll check the latest version, and then the group ID will be this, the artifact this, and then so what I'll do here, I'll just create this I'll just do this I'll put this side by side so that you can just learn together. I'll just put this side by side, and then you can follow through. So in here, said use Java, and then we use Maven, right? So after that, we use Spring Boot 3. So there's also Spring Boot 4 right now. You can use 3.5 this snapshot, or even 3.5.8. That means is at least a stable version of the same. So either of these you can pick even for the latest. And then on this one, I'll just say my group is this one.bula. Then this is Bula. Artifact will be S Bula gateway. Yeah, so I'll say Bula gateway. So we populate the rest. Service, gateway service, Bula gateway service. The gateway service project for Spring Boot. That's okay. And then we want to use Java, and then Java 17 or 21. So you can pick either 17 or 21. So I'll just pick 21 to be safe in terms of upgrade. And then here we have the dependencies that we need. So add the following dependencies. Let's say we add the reactive Spring Boot reactive, and then reactive web. We need Spring Boot cloud. Cloud gateway, just say cloud gateway. So Spring Cloud routing, that's it, the first one. And then Spring Boot actuator. So I'll need also actuator. Just pick the Spring Boot actuator, and then Spring Boot dev tools. So I'll know what all these dependencies do as we continue the project. So add Spring Boot Cloud Gateway dependencies on the POM. So cloud dependencies and version and stuff. So this is the management. All right, I see. So this for 23, 2023. So let's try and see what it will create for us first, and then we configure now the routes. So you can preview all these items and see whatever items that it has. But there is this part for management, dependency management, where they have added a version of a Spring Cloud version. So that's the only thing that is missing on my POM. Let me see if we can add it. Spring Cloud version, here you go. And, all right, it's here. So this one already done. It means our project is very ready. So we'll just download. So you can copy this and go initialize an app, or just download your app. It will download not POM. So I'll just close this POM, and then I'll say generate. So you can explore the POM or generate the file. So here we go. It has generated for us the Spring Boot app. And so I'll just open it and unzip it. It's here on the downloads. So let me just put it on the desktop. Where can I put it? Let me put it on the sandbox here. Let me put it on there. Let me even put it on the pictures. All right. That's okay. So let me just pick it from here and then put it in pictures. I don't have any other folders. And then, so I'll go to my IDE, which is IntelliJ. If you don't have such, you can get one community version or Ultimate, whichever. And then I'll go to my pictures and then I'll download that. So I'll say, yeah, trust this project also in the future. Yeah, so here is my project. It will give you a very nicely done. Let me see if I can increase this size a bit so that you can have a good or rather better view. Let me put it as 110. Yeah, I think that one you can see, or even 125. Yes, this one you can see. So here on the folder directory, you'll see it will create for me the source, Java, we have it here. There's resources, there's these application properties, and then remember there's our POM here that we previewed. Then there's these external libraries and stuff. So in here, we'll want this project first to load Maven. So you can either load Maven like that, and then I'll fix my internet issue and then have these fixed so that we continue the project, maybe project.